So a little intro to polar coordinates. We're going to start with, let's see, just x and y axis, something like this. And we've got a radius. And we'll put a point out here. This is just an x and y. It's just a point on a coordinate plane. And this is our radius. And this is our angle theta. Let me switch colors here. That's theta. All right, so with that information, we can drop this down here, and we have y distance, and we have an x distance over here. Okay, so then from all of that, what we get, well, using just our old rules of SOHCAHTOA, let's go ahead and jot that down. And I like to split it here, because we got some similarities between sine and cosine. Again, if you're using the tangent, you're not using the hypotenuse. So what we have is that the cosine of theta, using our usual, would be the adjacent over the hypotenuse. So that would be x over r. And that can turn into x is equal to r times cosine theta. Sometimes you'll put a little time symbol right there, sometimes not. All right, next we'll go back to sine. Oops, wrong color. And that's important. All right, so sine of theta is equal to y over r, which turns into y equals r times sine of theta. All right, so there we have a couple of formulas for x's and y's having to do with polar situations. The third would be tangent of theta, which would be the opposite over the adjacent, which turns into r sine theta if you were to use a little substitution from this guy and then this guy. So r cosine theta is on the bottom. Of course, the r's could cancel out, and you're left with sine of theta over cosine of theta, which matches with what we have been taught before. That makes sense. And then last but not least, just the relationship between x and y and r. So, of course, we've got Pythagorean theorem. X squared plus y squared equals r squared. All right, so there we go. We've got a few different formulas here, or connections. We've got our x's r cosine theta, y equals r sine theta. We've got tangent equals y over x, and we got x squared plus y squared equals r squared. And those are going to get you through most of what we deal with. Let me go box this up too. Okay. All right, continuing on. So we've got this, this point, x, y, out in the coordinate plane. It can be named by this typical xy Cartesian coordinate system, but we could also name it with a polar coordinate system, which would be r comma theta. So we need to know how far out did we go and what was the angle that we traversed in order to get to that specific angle. So let's go ahead and do a few examples of this, starting with, let's see, the directions are given the polar coordinates. So, and I'll even just write r comma theta here so you can see that one more time. So 6 comma 2 pi over 3. So that's your r, the 6 is your r, and 2 pi over 3 is the angle theta. We're supposed to find the rectangular. That's one way of putting it. In parentheses, we'll put Cartesian coordinates. So they gave us an r and a theta. We need to go find an x and a y. So if you'd like, you can go like this. R theta needs to become x, y. All right. Well, let's start with what we know. R is equal to 6. Theta is equal to 2 pi over 3. And we have a relationship between x and r and theta. It's up here. And then we got a relationship between y and r and theta. It's right here. So we're going to simply go x equals r cosine theta. And that means we can just go plug in the 6 and the 2 pi over 3. And likewise, we'll do the same for the y value. So we'll have y equals 6 times the sine of 2 pi over 3. So this will rely on you knowing your unit circle. So hopefully it's not too much of a stretch to get yourself out here and find out 2 pi over 3 has a negative 1/2 and a rad 3 over 2. Don't get them backwards, of course. First one's the cosine, second one's the sine. So let's see what this turns out to be. So we got x equals 6 times the negative 1/2. Y equals 6 times the rad 3 over 2. We'll just clean that up a little bit. X equals negative 3. Y equals 3 rad 3. And there we have it. We'll bring them together. Our new coordinates in rectangular or Cartesian style would be negative 3, comma 3 rad 3. All right, there you have it. Okay, we can do a little check at the end if you'd like. So let's switch it over here. You don't need to do this every time, but it's a nice little check. We should still have x squared plus y squared equal r squared. So we'll take the negative 3, square it. We'll take the 3 rad 3, we'll square it. And we'll find out, question mark, if that's equal to 6 squared. Let me change colors here. So square that, you get a 9. Square this, you get a 9 times a 3. Square this, you get 36. And of course, 9 plus 27 is really 36. Okay, that doesn't mean everything's perfect. You could have made a couple of mistakes and then it just worked out. For example, the negative sign. If you didn't have a negative sign there, the Pythagorean theorem will still work out. But that just means you put it in the wrong quadrant, possibly. So, all right, let's do another example. We got one more. Let me slide this down here. Example 2. So this time we're given rectangular coordinates. And they are negative 2 and negative 2 rad 3. That's an x and a y. And we're supposed to find the polar coordinates. So we're looking for an r and a theta. Okay, so there's a couple of different ways to get through this, but remember you've got these formulas over here, the ones we've highlighted in green. These are the big guys. So given what we're given, we need to work through this. Now think about what we've been given. Let me zoom this out a little bit. So we were given an x and a y. That's all we have right there, an x and a y. So thinking back to the fancy formulas we got, I have an x, but that's not going to help me when you're missing r and theta. I have a y, that doesn't help me when I have an r and a theta missing. Okay, over here we have y and x. We know those, so we could find theta right now. We also, for the last formula, we have x and y. We can find r. So right now I'm thinking these two guys, these two formulas will get us through it. All right, so let's start with r squared equals x squared plus y squared. We'll go find the radius first. So the radius squared should equal negative 2 quantity squared plus negative 2 rad 3 quantity squared. So that means r squared equals 4 plus the 2 squared would be a 4, the rad 3 squared would be a 3, so that would be a 12 over there. So r squared equals 16. So that means r equals plus or minus 4. We haven't talked much at all about the negative radius. So we're going to stick with the positive radius at first, and then we'll come back and talk about the other part, where it's negative radius. Next up, we'll have tangent of theta is equal to y over x. So that means tangent of theta is equal to negative 2 rad 3 over negative 2, which can simplify quite a bit. The 2's are gone, the negatives are gone, and you might just want to call that rad 3. However, I contend we would like that to still be over 1, and we would like to make the rad 3 on the top and the 1 on the bottom into some more familiar looking coordinates. So I'm thinking rad 3 over 2 and 1/2 makes a little more sense to me. Let me get you a little picture here and we can talk about where that is. So if they're both positive, that puts us up here. Let me switch color here. That puts us over here, and that would be at pi over 3. But we could also have them both be negative. So again, this is the, remember, this is the y value and this is the x value. So if I went right 1/2 and up rad 3 over 2, that gets to pi over 3. But we could also go left 1/2 and down. So that would put us over here, which is, let's see, 2 pi over 3, 3 pi over 3, 4 pi over 3. So we have two options there. So we have theta, let's call it theta 1 equals 1 pi over 3, and then theta 2 would be the 4 pi over 3. Okay, so we've got a few different answers we can give here. Let's start with the fact that we were at a -2 and a -2 rad 3. Well, clearly if you went negative and negative, it should be down here. So let's go write down that answer. So we go radius first. So we got our radius is 4, and then we're going to give that angle 4 pi over 3. Okay, so that's a great final answer. Or we could give a negative radius. Let me explain how that works. So let's say we're at this pi over 3. Let me go ahead and put the pi over 3 down. Well, if I'm at pi over 3, if that's my angle theta, and I really need to be down here because remember the x and y coordinates were both negative. Well, we need to land down here at 4 pi over 3, but we could use pi over 3 with a negative radius of 4. So both of those would be fair game. In fact, there are lots of different answers. Let me go ahead and rewrite this as 4 pi over 3 plus 2 pi n, if you remember that old trick that we used to pull to get all of the possible angles. And then we got another, or over here we could use -4, then we could say pi over 3 plus 2 pi n. Same concept. And what we mean by that plus 2 pi n is, you could be here, but you could add 2 pi and be back, and add 2 pi and be right back at the same place, and add 2 pi and be back at that same place. As long as we are landing here somehow, some way, it's fair game. All right, thanks for watching. We'll do some more in another video soon. See you later.